Welcome back, environmental reporting teams. Let's jump right into today's explainer. We're looking at a huge piece of your operational compliance puzzle, exactly how to measure air and water metrics using SASB and ISSB standards for the metals and mining sector. Specifically, we'll be breaking down the methodologies you need to track non-methane volatile organic compounds, particulate matter, and the water you consume in high-stress regions. Precision is literally everything here, so let's get straight to it.
Okay, let's dive into this. The whole foundation of what we're talking about today rests on the ultimate authority of the ISSB playbook. You probably remember that back in August 2022, the ISSB fully took the reins on the SASB standards. But what does that actually mean for you and your reporting teams? Well, it means the metrics we're exploring today are not just, polite industry suggestions. They are the definitive, global standard for regulatory compliance and financial disclosure.
Think of this as your syllabus for cutting through the regulatory density. We've got a highly structured guide for you today. First, the SASB reporting mandate. Then, tracking air quality metrics, defining PM10 and VOCs, navigating water scarcity, high baseline water stress, and we'll wrap up with actionable takeaways. Let's kick things off with Section 1, the SASB reporting mandate, navigating the global standard. So, the ISSB is absolutely committed to maintaining and evolving these standards. And remember, accurate reporting isn't just about keeping regulators off your back. It's about spotting operational efficiencies and avoiding massive financial risks. Under IFRS S1, you are required to use these exact SASB metrics when you identify sustainability-related risks. So, when your team sits down to pinpoint what could actually impact your company's prospects, precision is totally non-negotiable. Moving right along to Section 2, tracking air quality metrics, going from sky to spreadsheet. If you look at the extractives and minerals processing sector metrics, I want you to pay special attention to metric EMMM120A.1. The standards basically demand that you track a very broad, very specific range of pollutants. We're talking carbon monoxide, nitrogen oxides, sulfur oxides, particulate matter, mercury, lead, and volatile organic compounds. It's a massive, comprehensive suite of emissions that come directly from your smelting, refining, and transportation activities. Now here is a vitally important rule for your data aggregation: metric tons. When you're calculating all those direct air emissions, whether they're from stationary sources, mobile equipment, giant production facilities, or your transport fleets, absolutely everything has to roll up into metric tons, no exceptions. This is what guarantees we have a standardized, comparable baseline across the entire industry. All right, Section 3, defining PM10 and VOCs. Let's strip away the jargon so we don't hit cognitive overload. Now, what's really interesting about this slide is that under the SASB definition, PM10 isn't just everyday dust. It is strictly defined as any airborne, finely divided solid or liquid material with an aerodynamic diameter less than or equal to a nominal 10 micrometers. That's a mouthful, but the takeaway is this: if your monitoring equipment is calibrated to some other standard, your reporting is basically at risk of being fundamentally flawed right out of the gate. Next up, we've got volatile organic compounds, or VOCs. The standard defines these as any compound of carbon that participates in atmospheric photochemical reactions. But listen, here's where reporting teams stumble all the time. Over-reporting is a real huge risk if you aren't paying close attention to the exact chemical exclusions built right into this definition. We are specifically zeroing in on non-methane VOCs here. So the crucial point is that you have to mentally and systematically check off these exact chemical exclusions from your VOC data. We're talking carbon monoxide, carbon dioxide, carbonic acid, metallic carbides and carbonates, ammonium carbonates, and crucially, methane. Why? Because none of these participate in atmospheric reactions in the same way, or frankly, they're tracked separately. If you accidentally lump them in here, you're going to artificially inflate your VOC data and make your environmental footprint look a whole lot worse than it actually is. Let's shift gears to Section 4, navigating water scarcity, moving from the sky down to the ground. First things first, what are we actually measuring? Look, water scarcity isn't just some abstract environmental concept. For the metals and mining sector, it's a critical operational risk that can literally halt production. Now, if there's no local legal definition of fresh water where you operate, the regulatory baseline kicks in. And that baseline says fresh water is water containing less than 1,000 parts per million of dissolved solids. Anything above that 1,000 ppm threshold, that falls into a totally different bucket of your water management reporting.
Let's move to and see how this builds into a practical workflow for your teams. We can actually take a super dense paragraph of compliance rules and transform it into this really simple, clean, 3-step action plan. Step 1, identify all your water withdrawn and consumed. Step 2, cross-reference your exact operating locations with the World Resources Institute's Aqueduct Water Risk Atlas tool. And Step 3, calculate the precise percentage of your water metrics that fall into high or extremely high stress regions. See? Not so bad when you break it down. But hold on, what exactly counts as consumed water? When you're running these calculations, you absolutely must limit it to these 3 specific scenarios to stay compliant. First, water that evaporates during your withdrawal, use, or discharge processes. Second, water that gets directly or indirectly incorporated right into your final product. And third, water that just doesn't return to the same catchment area it was withdrawn from. Say if you redirect it to the sea or to a totally different basin. If it doesn't fit into one of those 3 boxes, it's simply not consumed under the standard. All right, Section 5, high baseline water stress. Let's translate those thresholds. And this brilliantly illustrates the exact parameters you're measuring against. According to the Aqueduct tool, a region is facing high baseline water stress if it scores between 40% and 80%. It crosses over into extremely high when it hits greater than 80%. But remember, these percentages are not just arbitrary numbers on a spreadsheet. They're real, tangible risk barometers. They're telling you your exact vulnerability to community competition for water, spiking costs, and the very real threat of having your operations curtailed. Which brings us to Section 6, actionable takeaways. Let's get to the bottom line. I know we've covered a ton of granular technical ground today, but bringing it all together, look at this comparison. Tracking your PM10 and VOCs accurately, that's what lets you proactively mitigate localized health risks and confidently navigate those increasingly strict global emissions rules. On the flip side, strictly defining your freshwater use and mapping it against those WRI aqueduct stress thresholds, that directly mitigates your operational scarcity and reduces community friction. It just goes to show that accurate SASB and ISSB reporting is absolutely not a box-checking compliance exercise. It's a vital, strategic tool for safeguarding your entire operation. I want to leave you with a question to take back to your teams. If the raw reporting data you calculate for these toxins and water directly dictates how investors and regulators view your operational risk profile, how confident are you that your current measurement protocols would survive a strict ISSB audit today? From your PM10 definitions to your VOC exclusions, it might be time to review your internal protocols and make sure your metrics are as rock solid as the standard demands. Thanks for joining me on this explainer, and happy reporting.